Welcome to the final video in the 2019 AP Calculus AB Term 1 Standard Quiz Model Overview series. In this final video, I'm going to go through the last question of the standard quiz, also a calculator-based question or graphing calculator-based question that asks you to compute a derivative at a particular point. So of course, if you have not yet gotten into the second unit of Calculus AB, you might not actually know what a derivative is. That's okay. This is actually something you can figure out how to do very quickly without much actual calculus knowledge. But I'm going to make sure in this video to show you both ways to do it, one involving the literal graph and one involving a series of keystrokes. That's really useful. As I did before on the last two calculator-based videos, I'm going to use a TI-84 plus CE graphing calculator emulator to show you what buttons to press and kind of where to go and show you all the shortcuts that I can. So first of all, in question number 14, it dictates for us to use a graphing calculator to evaluate the derivative of the following function at a point. So we're going to try to figure out what the slope is for this particular curve at a given x value, or the slope of a tangent line, if you will. So for us here, the first method I'm going to show you isn't necessarily the one that I use the most, but it's the most basic and the one I've used the longest. And that involves just graphing this function and then using one of the features of the calculator to find the derivative. So what we're going to do is we're going to go into y equals, just like we normally would, and we're going to put in this function. So first I'm going to put in the square root. As I showed you on one of the last videos, you can actually put in fractions really nicely by going to math, and then going to the fraction button and pressing n over d. So for simplicity, I'm going to do that here. Otherwise, I just have to use some parentheses. We'll have x squared plus 3 as the numerator inside the radicand, and x plus 1 in the denominator. So now that I've got it, I'm going to graph this function like normal. That's going to be zoom 6. So there's our graph function. We can see it all. It's all really nice. And we want to find the derivative at x equals 3. Well, as we mentioned before, derivative means slope. We basically want to figure out what the slope would be, or what is the instantaneous rate of change at x equals 3. So to get there, I'm going to go to the second trace button. And down there on option 6 is dy dx, kind of like delta y over delta x, or rise over run. So I'm going to select that. And then in here, I'm going to straight up put in 3, and then press enter. And the calculator will return two things for us. First, be careful, this returns x equals 3 and y equals 1.7320508. That is not our derivative. That's just the y value. It's telling you what the height is of the curve at that point, the vertical distance from the x-axis. What we want is the actual dy dx value. In our case, that's going to be 0.217. So in here, our answer is 0.217. We'd also accept the truncated version, which is 0.216. I'll also point out that although this is the answer that we're looking for, you could, if you wanted to, point out that since that's f of x and we just found the slope, we could call this f prime of 3 and say that it's equal to 0.217, or approximately equal to, because we cut off some decimals. So there's the first one. So the first option involved using the graphing calculator. To illustrate that one more time, it was second calc. It was option 6 down at the bottom, and then it was just typing in whatever value you were looking for to get the actual slope we wanted. Now our second example, part B. We have another function, e to the x plus 2 cosine of x power at x equals 3/8. So for this one, I don't want to do it the exact same way, although obviously we could. I want to show you a second way to do this. So what I'm going to do in this case is go back to y equals. I'm going to clear that first function, and I'm going to put in the new one. So that's going to be e to the x plus 2 cosine of x power. So there's our function. Now what I'm going to do is I'm going to exit the graphing area. I'm going to go back here, and I'm going to go back to the math menu. So in the math menu, down there on option 8 is nderiv. That is to calculate a particular derivative. So it says n, I believe, for numeric, but just in case, we're going to calculate the derivative at this point. And in here, I'm going to first have to tell it a couple different things. First and foremost, I need to tell it what variable we're using as the independent variable. In our case, that's going to be x. So notice it writes it in as ddx, just like we would if we were writing this out by hand. Second, we want to tell it what x value we want to evaluate at. So I'm going to go over to the far right side. I'm going to put in 3/8. So we want to evaluate the slope of this curve at x equals 3/8. And then last but not least, we want to put in the actual function. So of course, we could type in this function e to the x plus 2 cosine of x. That would absolutely work. And then when we press enter, it would give us our correct answer. But I want to point out to you that there's actually an even easier way to do this, and it involves using the y variables that our calculator automatically stores. So once again, if we go math and then we use 8, we tell it variable x, and that we want to do this at the 3 8's x value, we can actually go to alpha trace and select y1, and that will select the function that we put into the y variables before. And notice it gives us the exact same value we would have gotten before. So 2.502 is actually our value. So 2.502 is the slope we were looking for. And in this case, we're able to avoid having to graph the function because that might be slow. It just might be a little bit more cumbersome. We're able to find the slope that we were looking for in any event using math 8 as well as y variables. Okay, third, we want to find the slope of this guy. Well, in a sense, just from reading the question, we're going to be looking for h prime of 2 to figure out what that value is. Now for this one, I'm just going to punch it in. I'm going to go as quickly as possible here. I'm going to go to math 8. That's my personal favorite. Math 8, I want to put in the function itself. I don't want to have to type it into anything anywhere else. So tangent inverse of x plus 5 cosine of x. And then our x value we're doing it at is x equals 2. So again, we could have graphed this, would have gotten the same answer. In our case, though, we get our correct value of, got to see the number, negative 3.524. Negative 3.524. And of course, we'd accept the truncated version as well. 523. So there is our third example, just kind of a quick one to check yourself on. So that covers the basic skill. But now for the plus question, we involve a little bit more problem solving in here, a little bit more arithmetic and algebraic work to get there. So let's see. In question 14p, the question states, c of x is 4 plus k f of x for f of x from part A. So we're going to have to go back to part A again. Oh well, we'll deal with it. Then it says if c prime of 5 equals 11, find the value of k. So we've got a couple different things here. So first, I noticed that it's mentioning c prime of 5. I think it would be helpful then, therefore, to figure out what c prime of x is equal to. And that means we're going to have to differentiate 4 plus k f of x. Now 4 plus kf of x is just going to be a series of simple derivative rules. The derivative of 4 is 0. The derivative of a scalar times f of x is that scalar times the derivative of f, which means that our derivative is just k times f prime of x. So there's a good starting spot. So from here, we next have a little bit of extra information. We want to know, or we know that c prime of 5 is equal to 11. And we also know, since this is equal to c prime of x, we also know that 11 is equal to k times f prime of 5. So that means that if we want to solve for k, we can just divide both sides over here by f prime of 5. Whatever that is, we are going to have to actually do that. And we'll get our value we're looking for. So our problem now in this question is to go through and figure out what is f prime of 5. So to attack this, I'm going to use the graphing calculator one more time. Unfortunately, I do have to go back and re-input the first function. So I remember we did this. I want to say it was, let's see if I can use my memory, x squared plus 3 over x plus 1. Let's see if I was right. X squared plus 3 over x plus 1. X squared plus 3. X plus 1, nice. I remember some stuff. This is good. So in here, I want to figure out the slope at 5. So I'm going to do, clearing this thing out, math 8. I want to do this x. We have alpha trace y1. So that was our function, y1. We want to figure out the slope at 5. So there is our slope. Means this is going to be equal to, let's make sure I do this correctly here, equal to 11 over 0.205737. And you can see I'm keeping a lot of decimals in there. You never really know. You got to be careful and make sure you maintain accuracy on all intermediate calculations. But for our purposes, now that we have that value, we can approximate it. And in fact, in my calculator, I could store this as a variable. I could decide to store that answer we just got as alpha a. And then I could do 11 divided by a. That would be one way to get the value we're looking for. The other option could be, if so desired, I could take that and I could just do in my calculator 11 divided by the answer. And in both cases, we get our correct value, 53.466. So that is the value of k, or the approximate value of the k value we need, such that c prime of 5 would be equal to 11 here. So with that said, that concludes the 14th video in this series. We've now gone through all 14 question types and done all, I believe it's 57 questions that were included on the standard quiz model. Hopefully this video, like all the others, has been helpful to you, and may this help you conquer the standard quiz, whether you take the traditional version or the plus versions that we write each week. Thank you.